SAW welding, also known as shielded metal arc welding or more commonly as stick welding, is one of the most widely used and well-known welding processes in the world. It is a manual arc welding process that uses a consumable electrode coated in flux to lay the weld. An electric current, supplied either by an AC or DC power source, forms an arc between the electrode and the metal workpiece. This arc melts both the electrode and the base metal, creating a molten weld pool that solidifies into a strong joint. The distinctive feature of SAW welding is the electrode itself. The electrode is a metal rod, typically made of steel or a similar alloy, that serves two functions. It acts as the filler metal that is deposited into the weld joint, and its flux coating provides a shielding gas and slag to protect the weld area from atmospheric contamination. As the arc burns, the flux melts and forms a gas shield around the weld area, preventing oxygen, nitrogen, and hydrogen in the atmosphere from contaminating the molten weld pool. At the same time, the flux solidifies into a layer of slag that covers the weld bead, protecting it as it cools and helping to shape the bead. This slag must be chipped away once the weld has cooled. One of the primary advantages of SAW welding is its simplicity and versatility. The equipment is relatively inexpensive and portable compared to other welding processes, and it can be used in a wide range of environments, including outdoors and in hard-to-reach areas. SAW welding does not require external shielding gas, which makes it well-suited for fieldwork in windy or remote locations. This process is commonly used in construction, maintenance, repair, shipbuilding, pipeline work, and heavy equipment manufacturing. SAW can be used to weld a variety of metals, including carbon steel, stainless steel, cast iron, and some non-ferrous metals like aluminum and nickel alloys, although welding non-ferrous metals with SAW is less common and more challenging. The process is generally better suited to medium to thick materials, as it provides deep penetration and strong welds. It is also capable of welding in all positions, flat, horizontal, vertical, and overhead, making it very flexible for different types of jobs. Despite its strengths, SAW welding has some limitations. It produces a significant amount of slag and spatter, which require post-weld cleanup. The process is also relatively slow, especially compared to automated or semi-automated processes like MIG or TIG welding. Additionally, SAW requires a high level of skill and coordination. The welder must maintain a consistent arc length, angle, and travel speed, as well as properly strike and restart the arc, which can be challenging, especially for beginners. Improper technique can result in defects such as porosity, slag inclusion,